Hello, everyone, and thanks for joining the Ad Dot podcast again. I have with me today Lee Atchison. He's an author, as most authors of value have many years of experience, including a lot of experience at Amazon and retail and on the AWS side as well. Worked with New Relic, is now an independent consultant, and has a cool book. So I'd like to just introduce and welcome Lee, and if you will, please tell us about yourself.
Hi, Vaughn. It's great to be here. My name is Lee Atchison. I've been in the industry for about 30 years or so, but some of the most relevant parts started in 2005 when I started work at Amazon, and that's back when Amazon was just in doing retail. It was just doing books and electronics and a couple other categories. And what my first job there was is I ran the group that was trying to move Amazon from a monolithic application into a service-oriented architecture. So automatically I got thrown into in with the wolves on building large-scale, highly scaled service-oriented architecture and making all that work. And so I learned a lot about building those sorts of systems working at Amazon. And then when AWS started, I was asked if I wanted to join AWS, and I joined very early in the lifetime of AWS. And I built the Elastic Beanstalk service, which was the first platform as a service offering that they built on top of their infrastructure as a service offerings. And so led them into kind of a growth area with that. And Elastic Beanstalk is still a service today and still doing strong. Every once in a while I run into somebody who uses it for their application. So I was at Amazon and AWS for a total of about seven and a half years, then left and moved to a small company at the time called New Relic. And New Relic was in the analytics space and application analytics. And that company has grown to be several thousand people now. At the time I joined, it was just under 100 total people. It was a very small company. And while I was there, they grew and went through all the same growing pains that I did at Amazon. So it was kind of a trial by fire of bringing some of the experiences I had at Amazon and building scalable systems into New Relic. But I was at New Relic for about 8 years and then left New Relic, and now I'm off on my own as my own consultant.
Nice background. And I personally enjoy consulting. I like, engaging with a number of different clients and help them with both similar and completely different kinds of problems. Maybe you run into the same thing. So I suppose you chose consulting as, it's time to, see a lot more of the world of IT, I guess, and computing than you had in a few companies along the way.
Yeah, that's true. I think one of the things that I like doing is, the last 2-3 years at New Relic, after I finished writing my book, they took me on the road and brought me to, different trade shows and to customer meetings and to do book signings and all that sort of stuff. And that naturally got me engaged with, tons and tons and tons of customers who were, having the same sorts of problems that I was addressing in the book. And so I had an opportunity to talk to a lot of different companies. And I found that, that breadth of exposure to be fantastic. I'm one that loves breadth of exposure versus depth. And so I much prefer, dealing with larger problems and more of them than, deep nitty gritty, detailed problems. And so that's the sort of thing I like to do. And so talking to lots of companies and lots of customers and learning all the problems was a great experience and led very well into the consulting experience. It also led into a second edition of the book because everyone I went to had received my book and said, well, let me tell you about our experiences with this. And so I got lots of stories and lots of suggestions for improvements and things like that. and incorporated that into an updated version of the book later on. But it was a great exposure to be able to do that, and I always like talking to customers.
Well, it's a great way to get your feet wet with the consulting experience too, and getting all that feedback on your book. That's really excellent. So you wrote this book, Architecting for Scale. Maybe give us some background on it and what motivated you to write it, and tell us about maybe what changed from the first edition to the second.
Sure. So, I think as I mentioned, when I moved to New Relic, they were running into scaling issues, and they were growing pains were causing availability problems as well was happening. And what I discovered was I just came from Amazon, or at least came to Amazon a couple of years before, and all the things that I saw Amazon doing to solve scaling and availability issues, New Relic wasn't doing. And I saw them running into roadblocks and problems. And it naturally put myself into a position where I was teaching the development org and the operations org how to do some of these availability things and put processes and systems in place that I had learned from Amazon. And what I figured as I did all that is I was kind of surprised, but I was well accepted and well adopted and helped grow the company. And I figured there must be a lot of other companies that run into the same sorts of problems like that. So I figured that was a good opportunity to write about that. And so that's when I approached O'Reilly. They were eager to take on a book like that. And that's what led to the book Architecting for Scale. That was the first edition. As I mentioned, as soon as I did that, New Relic took me on the road to talk to customers, and architect for rent, come see the architect and buy New Relic while you're there. That sort of pre-sales model. And so I did a lot of presentations and a lot of customer visits at trade shows and things like that, and learned a lot from the customers that I ran into and the war stories. They'd read the book and said, "Oh, this solved this problem of ours really well, and here's the problem we had and how it worked and how to make it happen and whatever." And so that led to lots of ideas for the second edition. And so when O'Reilly approached me to do a second edition of the book, I had lots more stories to do. And I knew there was parts of the book that maybe didn't work quite as well in the first edition and other parts that needed to be expanded. So what I did is it's actually a significantly different book than the first edition. It has about 50% new content, and it's about 30% larger and about 50% new content. So there was some old content that was removed and replaced with new content, and everything updated, and a new section talking about cloud, which obviously was much more important as the years went on, and some other new content as well. And so it really is a different book now. So I certainly encourage listeners, if you've read my first edition of the book, you should read the second edition too. I think you'll find a lot more useful information there as well.
Yeah, I can imagine, because, well, things have changed a lot even in the past decade, even half decade. Things are, just really different, and microservices for one thing, and even function as a service, right? AWS Lambda, whatever happens.
Yeah, those are two new contexts. They weren't even really they weren't major items to be discussed at the time. And, back in 2016, containers was just becoming a thing, but not really mainstream yet. And, there was no Kubernetes or anything like that. There was no functions as a service to speak about. All that was new that came out after all of this. And all of that is now addressed in the book as well.
Yeah, although I guess Amazon in the retail side was kind of doing what I think a lot of people would call microservices. Maybe it was just thought of as service-oriented architecture, but, can you tell us just a little bit about that experience and, the Two Pizza team and...
Yeah, absolutely. Yeah. I learned service-oriented architectures from Amazon is really where I learned it. Their model really was, the the STOSA model that I talk about in my book really came from Amazon. And it's the idea of you have a single team that owns a service, top to bottom, front to back, everything having to do with how that service works. The development, the operation, the maintenance, the support, everything. And also owns the SLAs of that service as well. The running of the service. And that model, as far as of having small teams that owned individual services, created a really loosely coupled architecture, which really allowed the Amazon to grow to be a single application that was huge and had a large number of people working on it because it was all loosely coupled. And that model worked extremely well. You mentioned the two pizza team. That was the Jeff Bezos's term for the size of the teams that were to own and manage and develop services. And they were about 6 to 10 people. And the number of people it would take to feed with 2 pizzas is where that term came from. And while that model changed as the years went on, it was kept pretty similar to that. Most of the teams within Amazon were in the 6 to 8 people or 10 people range. When they got to be much bigger than that, they usually were split into smaller teams, and then the services divided between them and all that sort of stuff. So it was really a model that was very consistent and carried throughout all of Amazon retail, and continued as AWS was created and grew. They continued to use that same model in AWS as well.
Cool. I wonder too, like in my implementing domain-driven design book, my red book, I wrote about basically quoting sections of Pat Helland's paper on life beyond distributed transactions. And, he spoke of entities, partner entities, and things like that. Did that sort of, was that part of your world?
Not as much the formality of that. I mean, one of the things I will say, I think, about the Amazon culture is formal methodologies weren't as important as informal methodologies. But what was more important was, does this move us closer to being customer focused or doing what the customer wanted? And that was much more important than making sure we followed formal methodologies. So you very rarely heard formal processes and systems and procedures described or talked about. It was much more informal and much more whatever works, figure out how to do it, and then do it that way.
Yeah. Interesting. Yeah. Good to know. Now, okay, talk about one, complete change in technology, even beyond microservices and function as a service, AI, right? What do you see happening in the AI world, and what does that have to do with, various computing platforms and applications these days?
Sure. Yeah. AI, obviously it's growing in sophistication as well as importance. But, and it's, when we think about AI and modern applications, we normally think about, the business critical areas that AI is being used for, the image and video manipulation, routing, or language interpretation, Alexa sorts of functionality. Better be careful if I say Alexa too loud, she's going to respond. And forecasting, predicting, those sorts of business critical functions is what you normally think of when you think of AI and modern applications. But AI has been just as important in the IT operations standpoint of modern applications as well too. Analyzing log files, analytics. We focus a lot on AI in New Relic, identifying trends, indicating when problems might be coming in the future or when scaling needs might be happening in the future. Those are problems, large quantities of data that needed simple answers out of it. And that AI was very well suited for those sorts of problems. But more recently, AI has been also being used in the the IT development area as well, not just operations, but in development. You've seen a growth in AI-assisted development tooling. GitHub's created some new tools. You're seeing AI-related low-code tooling, like what you see from OutSystems and companies like that. And those have been growing in sophistication and capabilities and usefulness as well, too. The complexity is a huge problem in application development, and AI has been a tool that's been able to help in the operation space and more in the development space as well.
Interesting. Personally, I'm a little reticent in working with clients to jump to AI. In fact, I more so use the term machine learning or something like that, only because I don't want to sound, bandwagonish or something like that. But maybe there's a lot more, AI relevance even to what I'm working in than maybe I'm willing to talk about or I don't know, promote or at least suggest. What do you think about those kinds of, boundaries and differences?
Yeah, it's actually a good question. And this is something I'm certainly guilty of, and I know a lot of people are guilty of. When I talk about AI, I'm often talking about machine learning. And when I talk about machine learning, I often talk about AI. And I don't necessarily clarify the distinction between them as much as maybe I should. I'm not sure. But a lot of the things I was talking about really, like for instance, in IT operations for identifying trends and log files and things like that, that's as much machine learning as it is AI. But still ultimately and ends up with the same result, is a learning system that analyzes large quantities of data in order to figure out trends and come up with short results, the useful results. And that's, whether you talk about machine learning or AI, it's really all the same thing. They all accomplish the same thing. Now, I'm going to hear people are going to write to me after this podcast who are AI experts. They're going to say, no, they're radically different. But I think from the outsider's viewpoint, it's hard to really differentiate between machine learning and AI. And I don't think the differences are all that critical for the very highest level view.
Yeah. Interesting. One person described to me, AI as being basically using linear regression. And I don't know if that's really a good classification for it. I think there are several different approaches to learning, and maybe AI is even, I don't know, a bit beyond, how much model training do you have to do, right? How much human intervention is there, or human training of a model is there? Maybe that's where that becomes less and less. Maybe that's more where AI belongs. And, when it's the machine really, really learning a lot without having humans teach. For example, take NVIDIA, right? I don't know a lot about what goes on inside of NVIDIA. I have, done some research and so forth at various points. And I know at one time, their, driving systems and so forth were heavily based on people teaching them what different road conditions represented, right? Where they have a lot of
watch me drive and learn how to drive by doing that.
And then inform the machine, this means this. I don't know. Do you have any thoughts on how that might apply one way or the other?
Yeah, I think that's, that is starting to get into the real definitional difference probably between AI versus machine learning. Is AI is the machine learning of human interaction versus the machine learning of patterns within data. And there is a difference there. But I ultimately wonder whether or not, from the grand scheme of things, as we're talking, they're both accomplishing the same end result. They're just different means to get to the same results. And which one's better or not really is context dependent on the problem space and what's the best way to solve it. I can believe that analyzing human response to complex driving scenarios is a good way to get an AI to learn how to do complex driving scenarios. But I'm sure there's also a flip side where there's a lot of very rote, learn from a machine how to make things work. Like this is a square on a screen, and that's important to tell that that's a square, and this is a stop sign shaped symbol, and those sorts of manipulations. That's AI as well too, or in that case, more machine learning to figure out those sorts of pattern recognition and things like that. And so in the case of driving a car, you're getting both the human learning that goes with it and machine learning that goes into it. And so they're both part of the same system. And like I say, the experts will know there's a huge difference between them and call me on the fact that I'm kind of merging them together. But to me, most of the time, they're both means to the same ends. And so it's all part of the same. From a technology standpoint, from a vision of the future standpoint, when you talk about AI, you're talking about AI and machine learning. When you talk about machine learning, you're talking about AI and machine learning. They both play into the same realm, and they both fit together.
Cool. I thought of maybe
that's
a humor.
Anyway.
Yeah, no, it's fine. It's just a discussion, right? I think it's an interesting,
sure.
Way to, maybe thought experiment or something like that. I thought of a humorous way that might explain if you're really working in AI. So like when, OpenAI was announced and the, whatever it was, like the top 5 people who were hired for that, and they got like 80,000 followers on Twitter in 2 days. That's one way to tell, if you're really working in AI, anyway,
yeah,
so
that's amazing.
Yeah. There you go. The way to success. So what do you see when you work with clients, or even maybe in the past at New Relic? What are some of the biggest problems that you see at companies who are trying to modernize, maybe, catch the digital transformation wave?
Yeah, I think one of the biggest problems that companies that really want to go through a modernization effort, what they really face is complexity and complexity of the status quo. They have these large monolith gunks of applications, and they just don't even know where to start or how to get themselves out of the muck. And so, it's a how do I start? How do I get going? What do I do first? How do I get myself to a position where it doesn't make things worse rather than better? I mean, I've worked with companies that have started the process of modernization and just stopped because it was way too complex. It was too involved, and they ended up worse off than they were before. And so I think that's probably one of the biggest problems is complexity drives resistance to change, which drives lack of ability to modernize, even though it's that complexity which is tending to want you to become modern in the first place. Why you want to do it in the first place is to get out of the situation that's holding you back. And often this plays into the management structures as well too. Management will look at the application and say, we need to get out of this mess, but we also have these 20 deliverables and these 10 customers, and we have quarterly profits, and we have all these other things we need to do. That's all complexity and muck as well too, that gets in the way of the modernization as well. And it's very hard to find the culture of a corporation, the culture of a company that really allows you to modernize out of this gunk in a way that makes the company successful. And oftentimes you have to go down before you go up. And it's very hard. So I would say that's the biggest problem that companies run into is being able to start, being able to get themselves out of this complexity and out of this gunk to get into the position where they can build something better and more modern. as well as the corporate will to actually make it happen.
For sure. Absolutely. I mean, just to give you an example, I won't name or even describe any very specific situation I work with some clients, but imagine an organization that's on IBM mainframe, and they have, let's say, like 50 million lines of COBOL code. And just doing a back of the envelope calculation one day in a meeting, trying to figure out, okay, what to do about this. And you say, well, if we could find a way to convert 100,000 lines of COBOL code per week, what would it take to, completely eliminate or have an entire translation, right? Or something, whatever, from the mainframe code, to modernized. And it would be more than 10 years. I think for 50 million lines, it's like 11 or 12 years or something. And it's like, wait a minute, by the time that's done, it's not modern anymore. You got to start over. It's like, what's even going to happen in 5 years? So, I mean, one way to think about this, and it brings up something, I saw your newsletter, I think, arrived yesterday or something, and you mentioned low code or no code, right? Even. And, all the code that those mainframes are running is not that complex, right? They're moving data around, or they're forms or something like that. Why not, from a DDD perspective, why not purchase some generic subdomains that are maybe highly configurable? And why not with your supporting subdomains, why not use low code or no code solution? What basically as much as you can possibly get away with, right? Mm-hmm. And then go tackle those really hard problems as core domains in DDD. And I mean, even that's going to be a lot of work, but if you could somehow reduce 50 million lines of COBOL code that would need to be translated or whatever, not that that's even really possible, right?
Right.
I mean, like Amazon really has this Infinite I product, right? Which basically says, well, just bring your COBOL code over to AWS and we'll run it for you basically in a simulator, right? Or a virtual, mainframe, so to speak. And, it's very interesting technology and so forth. But I mean, you still have the problem that you have COBOL, right? I mean, that is just that they're just, how many people are you going to be able to bring out of retirement? And for how long is that going to last? And then there's just, just nobody is going to work. Not nobody, but like, 10,000 people at some point are just going to say, okay, I know enough about COBOL to help you. That's just not going to be sustainable among all these banks, financial services organizations, right? So, man, we have to think of really, really different ways to get out of that situation. And it seems like low code, no code could be used in very specific, less complex, more like supporting roles of the software rather than the core stuff that the, whatever organization runs mainframes right now, right? What do you think about that? I mean, maybe that's even what you're doing today.
Yeah. Well, it's interesting you talk about it that way because you're absolutely right. And I think back to when I started in this industry and that's back in the days when, assembly language really was a very common way of building large systems. And you wrote, if anyone remembers from the olden days, and not too many of us left that do that, I know, but an application you could write in a higher level language like C or Pascal or Java eventually, that might take, let's say, 50,000 lines. In assembly language, it would take 500,000 or 2 million or 5 million lines. And that level of complexity made it the same problem we're running in today with the COBOL code. The same level of problems that existed back then. And the solution we used back then was, we're not going to rewrite this code. We're not going to support this code. We're not going to move it to, this 50 million lines to a different 50 million lines. We're not going to do that. We're going to instead replace it with a higher level language interpretation of the same functionality. So we started moving up the value chain. We started using higher level languages in more and more places. I was back, in a day when I used C++ to build a device driver in Unix, and was written up in C++ journal for one of the first people to use C++ in a Unix kernel.
Wait, I got to pause right now. You too had an article in C++ journal, or what was it? C++ report. Which one did you say?
C++ journal. Yeah.
I can't remember. Maybe mine was Rex. What was his name? Rex Jasic or something was the, anyway, I'm sorry to interrupt you, but that made me excited. I was like, wow, that was a long time ago. Yeah. Cool.
But my point with that is, I was one of the first people to use C++ in a Unix kernel driver. Before then, everyone was using C and assembly language. And, now everyone, lots and lots of people use C++ for kernel level driver support. And then now we have languages like, then we move up the chain to Java for higher level functionality languages. And now we're moving into Node and Go and higher level languages on top of that. And we keep moving up the value chain, and as well as platforms, not just languages, but platforms for building complex applications. And the value chain keeps moving up and up and up, where we end up doing less and less to generate larger, more complex things. And I think the next evolution in this path upwards is low code and low code, no code. And I think what we're going to see is a move into building using low code to build large, sophisticated applications, where we're going to be replacing these 50 million line applications, or these 1 million line applications, or these 500,000 line applications in other languages with less complex low code applications that are doing the same thing. And that's going to take time. But what it's going to amount to when we do that is, we're going to, the further up the value chain you go, the more you preserve your ability to move that code into the future, because it's less complex code. Anyway, I think I see that as a model for how we can, in the long term, get out of this muck of too much code, too old of code, can't deal with it. What do we do? I think moving up the value chain and eventually into areas such as low code is the way that we're going to be able to make that happen. And AI-assisted development is going to be part of that.
Yeah, I agree. And I have to say, what's been very disappointing to me is software developers, engineers' response to the opportunity to use low code, because they view it as like, wait a minute, I can't bill as many hours as I used to with this client, or it makes no sense to me, because it's like, why do you want to spend your time digging through this mess constantly for years and years when you could just be done with it and develop really innovative new software, right? This is the key, because all those problems that were solved, 40 years ago, even something like that, like those are just not really the interesting problems to solve anymore. Let's get those out of the way and make them work in a modern, computing environment, and then innovate in the really interesting things, step into AI, step into machine learning, or whatever it is, solve new problems and
move up the value chain. I just cannot
understand why there's such opposition to that. It's like we're in, people with that idea, we're just infringing on, the rights of developers to to, give, just do this stuff continuously and bill hours and whatever their mindset is. It just makes no sense to me.
Yeah, it's crazy. Yeah, the number of people I run into, the number of articles I find of people writing against low code because they see it as you can tell they see it as an invasion to, the real world of programming. It's not real programming. It's for people who don't really want to program, and as such, it's insecure and it's all these other things. It's like, no, it's not. It solves those problems as easily as anything else does, and maybe even easier. And it provides value above what you're already doing. Why not take advantage of that? Why not use that? Why not let it help you move further up the value chain to do bigger and better problems? Simpler.
Exactly. We have an open source platform, the Zoom platform, my company, Kalele. And, it basically, you can start from scratch and just implement microservices or even well-modularized monoliths or whatever, but in a reactive environment. So it's a reactive-based platform. But you can use this designer to define a domain model, and we will generate, code all around the domain model, and we'll even generate most of the domain model. And all you have to do is go in and, fill in some spots in the to-do where there's some business logic, business rules, or something like that. And that's really the definition of low code. So, we're poised to be in that world, and like we can just almost eliminate even thinking about, okay, if I see an event from another microservice, how do I react to that? Well, we know how to dispatch that right into your domain model when we see it, right? So why would you not want to do that? Yeah. So anyway, maybe you, so we've talked about AI, machine learning, at least similar, if not really the same. Low code, no code. Do you see any other technology trends that will really be, have a big impact on the industry in the years ahead?
Yeah, let's see. We've talked about AI. We talked some about loosely coupled applications, and I think we're going to see a lot of focus on loosely coupled applications. And this is not just microservices. This is, using cloud services. It's using SaaS applications. It's application integrations. It's, you're going to see application architecture is more of a Lego building blocks, connect these pieces together sorts of problems domain than it is of the building, large, tightly integrated software. So that's kind of related to the low code, but I think the componentized, loosely coupled software is going to be another trend that continues. And then I can't forget about blockchain. I was kind of a latecomer to blockchain. I was skeptical of the whole blockchain as the next generation of the web mindset that you hear about now, until rather recently when I started thinking it through a little bit more and realized that what blockchain is really all about and what it brings as a technology to the internet is models for increasing trust, and trust between, companies and clients, between clients and other clients, or, users and other users. Blockchain is going to be useful for, trust in social media and transaction management and, in content attribution. Who made that quote? Who said that quote? Who's responsible for that quote? And not only from a copyright standpoint, but can you, if you said something, can you provide a path of who said it and the research that went behind it? And some of those sorts of linking together of data without having to depend on trusting large corporations to manage all of that, I think is going to be a very valuable technology direction that we're going. And, whether it's Web3 or whether or not that's a marketing term, I don't know. But I think blockchain itself is going to be very critical to large-scale modern applications in the future.
I see blockchain right now to be, for very practical use for things like, legal documents. Maybe, could be any kind of legal document, but legal documents, say around like property ownership or something like that. And so now you don't even have to worry about, keeping this in a, fireproof place or some, or even just in your garage or basement or whatever, wherever you can find to put this, or trust that you go to some, place and you can find this legal document, and how do you know it wasn't, anyway, there are just so many things that can go wrong with that. So, and having a permanent record of this doesn't have to happen like in 1 second or a half a second or 10 milliseconds, right? If it takes 5 minutes for that to happen, even, it really doesn't matter, right?
Right.
So I see that as some very practical use of blockchain. Now, what happens with cryptocurrency and all these things, I just really sort of like to stay away from that whole topic. It's so, I just
notice I said blockchain and not crypto.
Exactly. Exactly.
Yeah.
So yeah, I think there are uses for it, and I think we will, learn of new practical ways to use it. I think it is important, though, for whether blockchain becomes more performant, or I don't really know, but I guess we have to just, as consumers and producers and or like stores or whatever, that we just kind of have to get used to that we've been spoiled by everything happens somewhat instantaneously, right? And that if it takes 5 minutes for something to settle, okay, just you bought it, leave the store, right? Or whatever it is. And that because you saw this, it will be done at some point. Sort of like when you buy a book on Amazon, right? It's like, you don't actually even know if that book is really in stock, right? You don't know. Yeah. It might not be in stock, or it is at the moment you buy, but by the time they go through fulfillment and so forth, and that book might not exist. So maybe 3-4 hours later, you get an email that says that book was out of stock, and then they give you some options. Well, that kind of thing, I think, will not happen with blockchain, but maybe we just have to get used to this is very reliable, but it's not as fast as, NCR cash, like point of sales is right now today.
Right.
But, and I think too,
apologize for that.
Oh,
it's my dog. Sorry about that.
Okay. We can pause if you want to. Well, we can just say, okay, so Lee has a dog and the dog is commenting in the podcast. Okay, we're going to do that then. We won't worry about it.
Okay.
Now, what do you think, though? Okay, when you think of Web3, to me, the really dangerous thing is they're talking about decentralization, but actually, it's not decentralized at all right now. And the security around how to access the information that you have in a blockchain is really, really open and easily, whatever you want to call it, hacked, tapped, whatever. I don't even think hacked it's so easy. Just sniff.
It's not really hackable. It's the one thing about blockchain is it's all the information in the blockchain is public, but also attributed, right? So that's what's really makes it valuable. Is it's not good for storing secrets. No, it's absolutely not good for storing secrets, but it is good for storing information that you want to prove. So, if the whole world will know that this piece of information is associated with you, and no one can change that, and any variation of that ends up being owned by someone else because whoever makes the variation. And that's really what the value of blockchain is. And that's why it's valuable for things like contracts, right? Because, it doesn't matter if a contract, well, in a lot of cases, let's not say contracts, let's say deeds, like house deeds and things like that. All of that is public and available, and actually it's useful that it's public. What you care about isn't whether or not it's private. You care about whether or not it's attributable. Is this document that says I own this house, is it attributed to a reliable source of truth? And if it is, then you own the house. And so as long as you can separate that out and realize that you don't want to think about blockchain as a tool for privacy, you want to think of it as a tool for attribution. And then I think things help a lot more.
Yeah, for sure. I guess maybe it's still a controversy whether OpenSea had some breaches in security or something. So, I guess.
Yeah, there's certainly, I think there's there's how blockchain specifically informs around crypto, right, are implemented and the side effects of those implementations. And there's some security issues there that have to be dealt with and things like that. And it's not, I also don't want to, be the person that says it's blockchain, therefore it's secure. It's not that simple either. There's a lot to it than that. But the problems that you run into with stolen crypto, for instance, are more having to do with the processes that are on top of crypto and on top of blockchain and how they succeed or fail and how those work. And that's where a lot of the problems run into. In the case of crypto, companies like Coinbase don't change how you buy, how Bitcoin works, but they provide a process on top of it that still has all the same old school things like a username and a password and credential management and all that sort of stuff, and all those things that can be hacked. And
for that matter, a website. It's a website.
Exactly.
It's not decentralized.
Exactly.
It's a website, right? So you're running Web 3 over Web 2, basically. And
exactly. And it's still a large corporation, and in this case, a very large corporation that's responsible for it. You have to trust that company and all that sort of stuff. And that's all Web 2, right? That's all Web 2 stuff. I think we won't be in Web 3 until that requirement goes away, but we're not there yet. This real Web 3 they talk about is a long ways away, and we've got a lot of things to do before we get there. But it's not going to be companies like Coinbase and Amazon and Facebook that are going to be part of that. It's going to be some other entities that are distributed, and I don't know what they're going to look like, and I don't think anybody really knows what they're going to look like yet.
Yeah. I mean, this is very stimulating conversation, so I appreciate it. I don't want to sound like I'm against something or whatever. It's all forward-looking, and it's all, very future thinking, but you also have to be aware, like getting into it right now, you really have to be very well informed about what you're getting into. So yeah, it's exciting though. Look forward to more of that in the future. So, okay, maybe most large corporations with IT, they want to get their operations into the cloud, or they want to use SaaS, right? So how does that, how do you balance that with also, okay, first of all, what isn't going to go into the cloud? What will you have running on premise? And whatever your choice is, what about, how do you deal with security and integrity in your software?
That's a great question. It's actually a question I get a lot, and I actually try and write a lot about too. it's kind of a general perception, and it's been very prevalent in the past, and it's still prevalent even in the last year or two. And that is that the perception is that the public cloud and SaaS services in general naturally increase exposure to security issues and security vulnerabilities. In other words, if you put your application in your own data center, it's safe. If you put it in the public cloud, it's in the public cloud and it's insecure and not safe. And that perception lingers today. But actually, the opposite is true. If you build an application natively built for the public cloud, I argue it's inherently more secure than that equivalent application natively built for your own data center. And the reason for it is quite simple. The public cloud has best of breed tooling and sophistication built to keep their infrastructure safe. They invest heavily in keeping, whether it's AWS or Azure or Google, it doesn't matter. They all invest heavily in keeping the public cloud safe. And they provide tooling and best of breed expertise in how to apply that tooling to your application to make your application safe. And they script it. They tell you exactly what you need to do. And as long as you do the right things, you can build very, very, very safe, very, very secure applications. Now compare that to your own data center where you have none of that infrastructure. You're doing everything by yourself. And this half person or full person security person on your staff that's kind of there and knows a little bit about security, they're the ones that are keeping it safe and secure. Nothing wrong with that person, but that's not at the same level of scope as a 150 person security team that builds tools to make your application secure. So fundamentally, the public cloud is more secure than your own data center. And you can build applications that inherently use those capabilities. You're going to build an application that's more secure in a public cloud than you are in your own data center. Now, to a different extent, the same thing's true with SaaS providers. But I do make a distinction here that, with SaaS providers, there's a broad range of SaaS providers. There's what I'd call the quality SaaS providers that definitely fit into the same capability as public cloud providers. And then it goes all the way down the spectrum to ma and pa shops that have no security built in and very small SaaS applications. So you do have to pick and choose in the SaaS world and choose what I would call quality SaaS applications. But as long as you do that, you have the exact same situation there as you do in the public cloud. They lose if they have security problems. And so they invest heavily in keeping your data and your system secure. And if not saying they don't have problems, they do, but you're going to be less problematic in general in a high quality SaaS environment and a high quality public cloud environment than you are in a roll your own situation.
Yeah. In fact, I was going to say, Lee, what are you saying? No, it's not really more secure to have your own data center. Although I will say that there's been this sort of trend, at least, if you believe the sort of news and headlines and things that you're reading, or that I'm reading, that, companies are saying, well, AWS costs whatever it is, 3,000 times more money for bandwidth than it does for, if we have bandwidth in our own data center. Just things like that, right? I mean, it's like going to Morton's Steakhouse and ordering a baked potato, and it's like this $25 potato, and it costs them like what, 50 cents or 50 something, cents. So it's like, wait a minute, guys, why am I paying, 3,000 times or whatever it is for bandwidth? So some companies are saying, you know what, the cloud really isn't less expensive. And so they're looking, and I'm not saying this is overwhelming, but there are companies like saying, walking that back, saying, okay, we think our data center is better. What are they going to do? What do you think?
Well, so I challenge some of that too, and it's like you're right. There's anyone who says that the cloud is cheaper than on-prem is wrong, and anyone who says that the on-prem is cheaper than the cloud is also wrong. It's not that simple. It's in general the cloud, used the way it's designed to in cloud native applications, is cheaper than on-premise. However, almost to a fault, if you take an application and just do a copy port to the cloud, it's going to cost more to run. And that's because you're not taking advantage of the cloud, and you're not doing the things that make the cloud efficient, and you're paying the cost for that. Just buying a CPU in the cloud and running it 24/7 is more expensive than doing the same thing in your own data center.
Yeah, that's called lift and shift.
As long as
right?
you use it more efficiently,
yeah. So you're talking
better
about.
off.
Sorry, I apologize. You're talking about lift and shift kind of thing, right?
Exactly.
Just like
yes.
offload.
A lift and shift application is rarely cheaper in the cloud. It's usually more expensive. But a cloud native application is built the right way, and using the cloud the way it was designed to be used is almost always cheaper than doing the equivalent application in your own data center. So, the cloud is cheaper and the cloud is more expensive. And those are both true statements. So if I hear a company that says, well, we're moving away from the cloud because we found it to be too expensive, almost guaranteed the reason why that's the case is because they did lift and shift and failed. And they need to not do that. Now that same person, though, isn't using the security aspects of the cloud either. So they're not taking advantage of the cloud in any meaningful way. And they're not, the whole argument about the cloud being more secure than on-premise doesn't apply to them either, because they're not building a cloud application. They're taking an on-premise application and moving it to the cloud. That's a very different mindset. So that's why I tell people, lift and shift is a tool that helps in some cases for certain circumstances, but it's not a cloud migration.
Very true. Yeah. Cloud native is the way to go in the cloud, right?
Yeah, absolutely.
So, all right. So let's kind of maybe wrap up our discussion talking about complexity. Domain-driven design is, meant to help, as it were, tackle complexity or wrangle with complexity and to not to make the software more complex than it needs to be, but as simple as it can be, but no simpler, right? Is maybe a good way to describe it. Or you still have success in the face of complexity where you don't even know the right questions to ask, let alone the answers, right? So how do we balance complexity in the technology part of, the cloud or software development in general? How do we manage that complexity and not make the application or the area of expertise in which we're solving a hard problem, how do we not make that software more complex because the technology is complex, right? Does that make sense as a question?
Well, I think so. I think what you're really asking is, how do you manage complexity when its complexity is not native to the problem, right? It's
exactly,
if you,
or at least not kind of complex, right? There might be complexity
the
here.
Same type of complexity,
yes,
right?
There might be necessary complexity in the problem, the business problem that you're trying to solve, but how do you not make it more complex by how you're trying to solve it? Right.
So what I find is that complexity and technical debt kind of go hand in hand, right? They're different sides of the same coin. And so often when you talk about how do you avoid complexity, what I go back and tell people is, well, how do you avoid technical debt? And a lot of the same solutions work in both of those cases. It is something you need to work on. It is something you need to improve as time goes on. You can make your application have more technical debt by underinvesting or less technical debt by overinvesting. Same thing is true from a complexity side. But more specifically, if you say, I have a complex system, I have a lot of muck, and I want to get out of it, what do I need to do? And that's where it comes down to things like, start disconnecting the pieces and moving to more loosely coupled application components, and then focus more on generalization of use cases and reuse of those components. And will help. Those two things together will help a lot in trying to reduce some of the complexity and focus where your technical debt is, and be able to work on removing the technical debt over time. And then use people and organization methodologies like STOSA we talked about, and that's something I talk about in my book, to manage the applications, which allows you to pull the political organizational complexity out of the application as well too. It helps reduce that complexity and pull that out as well. And I always talk about the trinity of loosely coupled architectures: ownership, autonomy, and accountability. And as long as you have teams and services and systems that focus on all three of those, not two of the three, but all three of them, ownership, autonomy, and accountability, you can build a system that is, and you can make your system less complex, more usable, reduce complexity, reduce technical debt, and focus on your application business logic instead.
Yeah. So it's not the CAP theorem, choose two.
Yeah. No, it's not that.
So yeah, very good.
You need to focus on all three.
Yeah, very good advice. And pay the debt, right? Like, okay, your big ball of mud, or like you say, the muck, it's that way because you did not pay debt, right? So you're either bankrupt, technically bankrupt, or very near it, right? So you have you have the potential for having your application repossessed, so to speak, and
right.
or cancel, or as we would call it, canceled. Yeah. So, but now you're creating new software, and you have the opportunity to pay debt. Just don't let that lapse.
Don't
like
follow
you did.
old patterns.
Right. Don't follow the old patterns. And I think you need some real maturity to lead by example in that way. Right. So if your organization has not succeeded in that for quite a while, you might ask, are we going to be suddenly able to succeed in the future, or will we just start ignoring debt when features have to ship, so to speak? And that's where we're headed once again. And then you mentioned something very interesting, the political side, or even just organizational communication, right? As Mel Conway said in Conway's Law is, okay, if all this weird communication and bad vibes are happening, you're going to have that reflected in your software. Is that sort of what
right.
you're saying?
Yeah, exactly. Yes. It's amazing, but if you build an organization that has complexity, you're going to build complexity in your software. If you build an organization that is hard to maneuver and hard to work through, you're going to build software that's hard to maneuver and hard to work through. And it's Conway's Law works. It really does, and not just the structure of the software, but the feel and the complexity and the flow and the lack of flow and the resistance is all parallel as well.
Well, it's been a very cool conversation, very stimulating and enlightening, and I appreciate it very much, Lee. So what are you looking forward to in the future? You're going to get to travel to Europe again, or?
Oh, I hope so. Yeah.
Yeah.
Yeah, I'm trying to, did like one trip last year, and I was planning on making reInvent last year my step back into large, forums again. But last minute, I changed my mind and says, that's too early. It's too early. So now I'm making reInvent this year, that forum where I go back into it, and we'll see what it's like. But I haven't started significant travel yet. I've had, like I said, I've been on an airplane once in the last 2 years, and I just don't see it happening sooner rather than later. And one of the nice things I've noticed too is that it's not really kept me from doing my job. There's certain things that fall by the wayside. There's certain things that you miss with direct human connection. And, certainly in the consulting business and, when I was at New Relic and talking to customers, there are certain things you accomplish over a drink. You just have to do that. And those things are probably going to become some collective debt over time that become a problem. But for the most part, Zoom works, and I'm able to do most of the things I need to do for business without having to travel. It's hard to do a book signing when you, over Zoom, but
yeah, well, it's a lot more expensive.
One of the big one.
Yeah, because you have to have, first of all, you get the book, you sign it for the person, then you pay a lot of postage to have this sent, and if it's going to Europe, that's not so ideal.
I've sent signed books to Europe, to Germany specifically, and had huge bills. It's amazing how expensive it is to send heavy items to Europe.
Yeah. Well, maybe we just thought of a service, right, where someone could take our signature and best wishes or whatever, and somehow stamp them in the front cover or title page of the book or something. And I don't know. Anyway, well, it's been a real pleasure, and I look forward to one day we'll run into each other, hopefully, and be nice to catch up. And
that'd be great.
Yeah. So
thank you for having me on your podcast, and hope it went well, and certainly let me know when it's published.
I sure will, and we'll talk to you again soon. Thank you.
If I could throw in one little plug at the end, if anyone wants to reach me to talk about, either to get my book or to, I'm working on a couple of other books as well. I'm working on a book for O'Reilly and another book as well too, as well as another book for Redis. I've got one book with them, and I'm working on another one. Feel free to take a look at my website, leeatchison.com, and there's also information there. And if you want to hire me to bring me into your company, either to speak to your engineering team or to help you solve a problem, I'm more than glad to help out as well.
Cool. And hopefully this conversation is a good indication of the quality that companies will get from that. So, yeah.
Thank you.
All right. So, do that. And we will have your domain name on the bio.
Thank you.
Okay. Take care.
Take care.